A lot of the particles that we have made so far look sometimes maybe a little boring. Like, we've made this little lightning effect, and we've also made this squirrel noise effect, which looks interesting, but all of them still rely on the default materials. And if you really want to make interesting looking particle systems that really take the visuals of your game to a next level, you're going to need to make particle systems with their own materials, or at least custom materials that you use for multiple systems, whatever. That's the entire reason I ended up doing an introductory course to materials before I started with this particle series, because I want to make sure that you guys understand the basics of materials, how UVs work, how multiplying colors works, all that kind of stuff before jumping into this, because everything we've done so far has just been about simulating the particles and effectively just giving them a position. Visualizing them is done 90% through the material. We can set up a lot of data inside of these simulations, but then how it actually gets interpreted and used in the material is what makes your particle system look the way it does in the end. And that's what we're going to be looking at today. So let's make ourselves a new emitter here. So we're going to go in Effects, Niagara emitter. Let's start with the omnidirectional burst in this case. And we'll call this the material viewer, because that's what we're going to be doing. We're going to be viewing materials. I'm going to change a couple of things right off the bat though. I want to disable the gravity force. I want to not scale the sprite size for the time being. I want the initialized particle size to be like a fair bit larger, so that's like 25 to 35, and that is a little bit better already. Did I say scale sprite size to 0? I did. And now we've got something that we can work with. So if we go into the sprite render, we're going to be doing all this based on sprites. Of course, it effectively works the same with meshes, because everything in the materials is just going to take this same information and apply it to the meshes output instead. We're going to do this with a sprite renderer because it's just a little bit easier to get into. We have our default sprite material. If we open that up, we can see it has a two-sided sign, which is just to make sure that it renders on both sides, which it does fairly well. Also, this is now rendering on a sphere. When you're displaying particles, usually you render it on a plane. So we have that going for us. It uses the particle color, and then it has a sphere mask here, which could probably just be a gradient instead. I don't know why they use a sphere mask, but sure. This is the default sprite material, and we're going to be making our own that looks a little bit like this, but has some more going for it. So let's make our material here, and we'll call that new sprite material. I'm just going to steal the sphere mask here. Again, I think using a radial gradient makes more sense, but sure, let's go with the sphere mask. And when we open that up, there's a couple of things that we immediately need to change. Because if we go back into the default sprite material here, we can see it is set to surface, which makes sense because particles still are surfaces. But the blending mode is additive, and the shading mode is unlit. So let's go back into our own sprites, or our own material rather, set it to display on a plane. And then we've got our blending mode, which is opaque, and our shading model is default lit. If you are working with your materials and you feel like you need to have a lit material, something that interacts with the lighting, you need to have something opaque, go for it. 99% of the time, you're going to want to have that additive and unlit setup. And the reason for that is that creates those little see-through particles that when you add and layer them on top of each other, they start becoming more and more bright as well. And you use the emissive color output for them. So let's put our sphere mask into the opacity, and then just real quick set our default color value alpha all the way. I don't think alpha actually matters in emissive color. It might, I don't know. And I'm going to set the hardness for this to being like 0.9, so it's a little bit harder to look at. Well, it's not harder to look at, the edges are just harder, which makes it nicer to look at, as a matter of fact. Anyway, you can see that it is culling the back face, and the way they fix that in the default sprite material is using the toSign node. That's fine, that works. It's probably not going to be an issue, because most of the time when you're using sprite-based particles, they're going to always be aligned to your camera. So you don't need to render the back face. Personally, when you do, I like to just set this as a two-sided material, and that way it just renders on both sides. So make of that what you will. We're just going to keep it as one-sided because it's slightly easier to render, especially if you're spawning like 1,000 of these, right? It does add up at some point. Now, let's set this as our new material here, and we'll start working with that. So new sprite material. We do need to apply our settings to it. And let's just try to set our particle color, right? So in instantiate particle, we can say, I want a blue particle, and it's not doing anything anymore. And that is because we don't have any particle color. We are setting our emission color, our output color, just straight to white. Unlike our default sprite material here, which uses the particle color node. So let's look for the particle nodes, and there is a bunch of them. And when I say a bunch, I mean a bunch. We have the particle color, direction, their position in world space, their radius. They all have a random value. Every single particle, when spawned in, gets a random value between 0 and 1, which you can use in materials, often for like offsetting textures and that kind of stuff. Their relative time, which I believe is just a normalized age. Their particle size, which is different from radius. We'll get into it. There's a bunch of these things that you can use. For now, the most important one, of course, is going to be the particle color. So we can just hook that up into here. And then our sphere mask, we multiply that by our alpha from our particle color. And this effectively just makes the default sprite material again, but it also multiplies the RGB with 0.15. It does like some stuff here, which I honestly don't care about. This is a much more simplified version of the same thing. Now, let's say that instead of setting our particle color, we want to also then tint that with a like blue to orange color tint on top of the particle color as the lifetime goes on. So the way we could do that is we could just take this and either multiply or add to it. I'm going to just add to it because it's a little bit simpler. We can do that into the emissive color, and then we can get a lerping node here. And we're going to be lerping over the lifetime. So we can, again, get our particle, and that's the particle relative time. If you're not sure what a node does, you can hover over it with Control and Alt, and this says particle relative time outputs a number between 0 and 1, representing a particle's age, 0 being the moment of birth, and 1 being the moment of death. So actually, as I started recording this, I figured that this is what it would do. I wasn't 100% sure, because I've been using it like that for a while, never actually bothered to look it up for sure. It is just the normalized age. So that's going to be going into our alpha here. And then what we want to do is we want to add two constant colors. I think I said blue to orange, right? So let's make this one blue. And then at the end of their lifetime, they're going to be orange. And they will still have their other color added on top of whatever this is. Really, what you probably want to do is you want to then divide this by 2. Just so that you don't like overexpose it. And now you can see they start out as being blue, and if we just go into the scale color and we don't scale the alpha real quick, you can see that they will toward the end of their lifetime become more orange. But our particle color still will work. So if we go into our initialized particle, it's because they start out as blue as well. If we just start them out as white, you can see that they fade more from blue into orange. But we can still, again, apply these colors to the particles, and they will get a little bit mixed together. So that's quite nice. That's the very basic stuff that we can do. But what now? We're still just fading them out very boringly. These things are just literally still circles. We want to have a little bit more definition to them, right? So that's where we start putting in our texture samples. We're going to be using a standard Perlin noise. And here we're going to be doing some wacky stuff, which is always fun. I like working with particles because you get to do weird stuff, and it ends up actually looking kind of cool. If you do weird stuff in code, your game breaks. If you do weird stuff in Blender, in modeling, your performance dies very, very quickly. If you do weird stuff, like if you do very weird stuff in particles, your performance still takes a hit, but you get away with a lot more, and usually it ends up actually looking kind of cool rather than breaking everything in sight. So that's why I like working with particles. So we're going to be using this alpha value, and we're going to be kind of lerping through this texture. And the way we do that is we subtract the texture from the alpha. And that is then going to go into this multiply node instead. So we have it at the bottom here. And that's going to make it kind of disappear right off the bat halfway through though. because of course, if we have an alpha of 1 and we are subtracting the texture from it, obviously we're not going to be fully opaque anymore. That just makes sense. But what this will do is if we go through here and we actually let's increase the size of this texture by going in and adding texture coordinates for it at 10% of the size, so that it's a fair bit bigger as a texture. And then if we put on in the scale color the alpha again, you'll see that it kind of scales out in a much more pleasant way right now, right? It uses that noise to kind of loop through the noise as a alpha matte, which is really, really nice. But it starts already halfway faded out, and that is not really, really nice. So the easiest way to fix that is to multiply this by, honestly, any value, at least a value of 2, because that makes sure that the alpha that we're using as a input, when it is full, is going to be a value of 2. And even if we subtract the brightest out of the brightest pixels of this texture, it's going to still have a value of 1. So it's still going to be opaque, at least as opaque as a additive material can be, as you will see. But as the alpha itself starts to approach 0, the influence of the subtraction from this is starting to be more and more and more. So you can actually set up kind of like a influence curve. If you multiply this by 4, this won't start being influential until very late into the alpha curve. It's much easier to just set that up with a literal curve though in the material. So just multiply this by 2 and leave it at that. And now the particles spawn in as full circles and then they disappear in this much more noisy way, which makes them feel a lot more interesting to look at right off the bat. Like this much detail and this much extra stuff going on, if you were to simulate this with individual round particles, you would already be spawning in millions of particles for something simple like this. Relying on some of material stuff makes this a lot easier to do. We still have a couple of small issues, that being they all have the exact same pattern when they fade out, which is not nice. And there's still a little bit of an issue with the noise itself also scaling up with the particles. So we should probably look into both of those things. Well, the first thing that I want to look into is giving them all a unique pattern. And that's actually remarkably easy, because what we can just do is we can get that particle random and just use that as an offset. So we're just going to be adding the particle random to our texture coordinates. And now all of them are going to have a random offset in the X and the Y direction. And they're going to, as a result, all have a slightly different pattern that they use to fade out. And immediately you can see how much more organic this looks. For the next thing, I'm actually going to increase the sprite size even more. And we're going to use scale sprite size again. And I'm going to scale this up by 4 times so that the sprites are nice and big. And you can kind of see, actually, I'm probably going to set the spawn burst instantaneous to just 1 sprite for the time being. And I'm going to give it no velocity and no drag, so that it just spawns in and then disappears. If we make this scale up and then set its lifetime to a little bit longer as well, so that we can actually properly see what happens here. If this scales up, you can see it also scales up the noise texture, which can be fine, but sometimes maybe what you want to do is, because you want to imply that it kind of fades into the air, right? It fizzles out, kind of like a flame, or I always think more about soap bubbles when I see this kind of pattern. So we want this UV to scale with the size of the particle. Well, wouldn't it just happen to be that we have a particle size node? We also have a particle radius node, and I want to talk about both of these next to each other real quick, because you might think, oh, we use the particle size, but if you Control and Alt, you can see that particle size is an expression of the X and the Y size of the particle sprite. So this is actually a vector 2. This has 2 components to it. The particle radius is just a float value. So for what we are using it for right here, I'm going to be using the particle radius because it makes a lot of the math a bit more straightforward. You can use the particle size, at which point you could start making squished and squished and whatever rectangles that still display this texture properly, because the texture is then getting opposingly squished and stretched and whatever. You can probably figure that out on your own. We're just going to stick with the particle radius for now. The particle radius we're going to divide, or rather we're going to be using that as the divider. We're going to be dividing 1 by the particle radius. So if our particle radius is just 1, the output here is going to be 1. If our particle radius is 10, this is going to be 1/10 or 0.1. If our particle radius is 50, this is going to be 1/50th or 0.02. So the larger this value is, the smaller the value coming out of this is. And if you remember back to our UV math video in the material series, the smaller this value is, the bigger our tiling is going to be, the bigger our texture is going to appear as. So that means that the bigger our particle is, the bigger our material will display, which means that it effectively is just going to display it as if it was in world space, at least as far as scale goes. Now, you probably do actually want to divide this by another number, like let's say like 250, as just a general like scaling number. But then we need to also get these textual coordinates and this particle radius stuff all both together into this divider before that goes into the texture sample itself. So how do we do that? Well, we can simply just divide them by each other as well. So we take the textual coordinates and we divide it by our particle radius thing, and if we put that into here, that will then make everything... I set this to 5,000 to test off screen. That's way too big. Let's set it back to like 200, like 100 maybe even. And now you can see the noise texture does actually properly scale up with the particle. There is still the issue that it scales up a little bit weirdly. It feels like there's a little bit of sliding going on here, which is why does that happen? Well, that happens because it scales it from the top left position. So when it scales up, it's actually scaling in this direction, creating that sliding. We want it to scale from the middle. So what we want to do in our UV space is we want to say, hey, our UV space doesn't start here. It starts 0.5 offsets in both directions. And the way we can do that very, very easily is just take this and we add a subtracting node here. We're going to be subtracting 0.5 from it so that we can divide that. And the reason that we're subtracting instead of adding here is because of the division node. We want this to not get too big as a value. And now you can see there is not much sliding going on anymore. There's still a little bit of sliding going on due to just simple like movement and stuff like that, but the moment we start adding in back our velocity and our drag and we spawn in like 50 of these guys again, we can start seeing that maybe we even want to initialize the particles to only be like 1 to 2 seconds long, and we can start seeing that we kind of have this weird firework soap effect going on now. And with all this, you can see there's a bunch more things that we can do. We can maybe set a color fade based on the speed of a particle. As a matter of fact, let's just do that, just have a little bit of fun. So we have the particle speed, and instead of using our relative time as the alpha for this loop that we set up at the beginning of the video, let's do this as the particle speed divided by like 100, because this is not a clamped value. Like the relative time is. If you just go over this, this is just the current speed each particle is traveling. So this is a velocity measured in unreal units per second, so that's centimeters per second. So if a particle is moving quite fast, it's going to be blasting past the value of 1 instantly. So what we want to do is we probably want to divide it by like 150, and then to make sure that we don't mess anything up, we want to saturate it so that it is always between 0 and 1. And now instead of going between blue and orange based on its lifetime, what it will be doing is it will be going between blue and orange, and let's actually set the color here back to white so you can really see the blue and the orange based on its speed. So we're going to set the lifetime back to something a little bit larger again, and we'll set the drag quite high. So there you can see when these particles initially spawn in, they are orange because they are moving quickly, and then the drag slows them down and their color changes proportional to their speed. Of course, with this type of lifetime, we then want to go back into the scale color and we want to go, hey, we actually want to scale this probably down a little bit sooner and all that kind of stuff. But you get that point, right? So that is particles with materials. really, if you want to play with particles, you need to understand at least the basics of materials so that you can set up stuff like this to make your particles look a lot better. Because again, if you wanted to make this like detailed, noisy stuff, you could just spawn in like a million particles and make something that looks similar to this effect, no doubt. But you would be over-engineering it and it would be underperforming. And you could only like literally spawn in one of them before your computer melts. So the value of proper materials cannot be overstated. And for the full course, if you're watching this in the future, it should be all up on the YouTube channel already. But if you're watching this shortly after it was uploaded, there will be a link down below in the description to the Patreon where you can find the full course. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. A huge thank you to my Cave Student tier supporters, Earl Monseval Erno, and my Cave Digger tier supporters, Sir J. Thomas,